In this video, we're going to talk about how to take derivatives of functions like these. In fact, we're going to do each of these examples in this video. But notice these are not just polynomial functions. We've talked about how to take derivatives of polynomials in previous videos. These are functions that involve things like square roots or quotients of functions. So like 18 over x here. Now, remember the derivative of a quotient is not equal to the quotient of the derivatives. So in other words, we can't get the answer here for what f prime of x is by just taking the derivative of the top divided by the derivative of the bottom. That doesn't work. Okay, so it's not just going to be 0 over 1. That's not going to be the answer. Same thing in part G. You can't just take the derivative of the top and divide it by the derivative of the bottom. That'll be the answer. You can't do that. In fact, in a future video, we'll talk about how you take derivatives of quotients using something called the quotient rule. And same thing with products. You can't take the derivative of this function here just by doing the derivative of the first one times the derivative of the second one. That'll give you the wrong answer. Okay, and again, in a later video, we'll talk about something called the product rule for how to take derivatives. In this video, though, so for parts E, F, and G, we're going to simplify the functions ahead of time, then take the derivative. But for pretty much all these examples, we're going to use a generalized version of the power rule that we've previously talked about. So let's recall, what does the power rule say? The power rule says if f of x is x to the n, then f prime of x would be n times x to the n minus 1. So for example, if you had f of x equals x to the ninth power, okay, what would f prime of x be? Well, it would be 9x to the 8th, right? Notice in this case the n is 9, so the derivative would be 9x to the 8th. Well, could we use the power rule to take derivatives of functions like these ones here? So notice down here we have the cube root of x. Here we have 1 over x to the 5th power. And again, we can't take the derivative of 1 over x to the 5th just by doing the derivative of 1, which would be 0, divided by the derivative of x to the 5th, which would be 5x to the 4th. That's not going to work. But could we still use the power rule in some way to take the derivative? And it turns out we can. In fact, what we can do is rewrite this as x to the negative 5th power. Remember, x to the negative 5th is the same thing as 1 over x to the positive 5th. And notice we can now use the power rule. Now, in this case, n is a negative number, right? N is negative 5. Okay, but the power rule works even if n is not a positive number. N could be a negative number or even a fraction or a decimal. The power rule is still going to work. So what would be the derivative in this case here? Well, notice f prime of x is going to be, well, we have to bring this number out front. That n goes out front. It would be negative 5 times x to the, and you might be tempted to say like negative 4th, but actually we have to subtract 1 from the n. And if you lower negative 5 by 1, if you subtract 1 from negative 5, you actually get negative 6. Okay, so negative 5x to the negative 6th power. It's not negative 4th, it's negative 6. Now, you could leave that as your answer, or you could rewrite this. In fact, it's good to know how to do this. Remember, x to the negative 6 is like 1 over x to the positive 6. So you could write your answer like this, or like this, negative 5 over x to the 6th power. Okay, so either of these would be correct answers. Okay, they're just simplified a little bit differently. Now, what about the cube root of x? Well, remember, the cube root of x is the same thing as x to the 1/3 power. Okay, so notice we can use the power rule where n is 1/3. And when we use the power rule, the 1/3 will come out front. And then we're going to have to do 1/3 minus 1 up here. Well, what's 1/3 minus 1? It'll be negative 2/3, right? So f prime of x will be 1/3 times x to the, and it's going to be 1/3 minus 1. It's really like 1/3 minus 3/3, which is negative 2/3. Okay, and we'll leave our answer like this. You could rewrite it as 1/3 times 1 over x to the positive 2/3, and just rewrite this as 1 over 3x to the 2/3. Okay, and that would be totally fine. In fact, x to the 2/3, you could write it in a couple different ways. You could write x to the 2/3 as x squared, and then take the cube root of x squared. Okay, but let's just leave our answer like this right here, 1/3 x to the negative 2/3 power. Okay, so let's remind ourselves too, what is a derivative? What do we mean by derivatives? Why are we taking derivatives? Well, remember, derivatives have to do with slopes, the slope of a function. So let's look at an example like this. F of x equals the square root of x. Find the slope of the tangent line at x equals 25. So in other words, find f prime of 25. So let's look geometrically here at what we're trying to do. What we're trying to do, so I've graphed the function right here. Let me remove these things. Here's the function, the square root of x. Okay, and let me draw in the point 25 comma 5, and let me draw in the tangent line. Okay, the tangent line that's there is in blue. Now notice I can move actually the point to different places here, and notice what's happening to the tangent line. The tangent line is moving. But if we go back to 25 comma 5, and we know that point's on the graph, by the way, because if you take the square root of 25, you get 5, and our function is the square root of x. Okay, so the question is, what is the slope of that tangent line? Right, notice it looks like it's a positive slope, certainly, but it's kind of a gradual slope, very gradual slope. Now, if the point had been closer in here, so for example, if we looked at the point 9 comma 3, okay, the slope is a little bit steeper. In fact, if we go further over here, the slope is even more steep. Okay, the slope of the tangent line. But at 25 comma 5, what is the slope of the tangent line? So what we're really trying to find is f prime of 25. Okay, so how do we do that? Well, f of x is the square root of x, but the square root of x is x to the 1/2 power. Okay, so you really need to know your properties of exponents here. So what is f prime of x? Well, according to the power rule, f prime of x is going to be 1/2 x to the, well, we have to do 1/2 minus 1, which is going to be negative 1/2. Okay, now we could leave our answer like that, but let's rewrite it as 1/2 times 1 over x to the positive 1/2. That'd be the same thing as 1/2 times 1 over the square root of x. And that's the same thing as 1 over 2 times the square root of x. Okay, so the derivative is 1/2 x to the minus 1/2. But x to the minus 1/2 is the same thing as 1 over x to the positive 1/2. And x to the positive 1/2 is just the square root of x. Okay, so what's 1/2 times 1 over the square root of x? Well, it's 1, right? Multiply the numerators, we get 1. Multiply the denominators, we get this. So that's f prime of x. Well, what is f prime of 25? Well, plug in 25 for x. So you could either use this formula here, or you could use this formula here. By the way, I'm putting a box around it. That's not our final answer. Our final answer is going to be what f prime of 25 is. So let's plug it in. We get 1 over, let's use this one right here, 2 times the square root of 25. So that's 1 over 2 times 5. And so that would be 1/10. Okay, so the slope of that line, the slope of that tangent line right here is 1/10. Okay, that's what f prime of 25 is 1/10. Okay, but notice we use the power rule to find the derivative of x to the 1/2. Okay, so let's go ahead and do those problems a through h that we mentioned here. How would we find the derivative of something like 18 over x? Well, we can rewrite this as, you could write it as 18 times 1 over x, but that's the same thing as 18 times x to the minus 1 power, because x to the minus 1 is like 1 over x to the positive 1, right? 1 over x. So we're going to rewrite 18 over x as 18 times x to the minus 1. Now let's take the derivative. What's the derivative? Well, if we take the derivative of this, we multiply the negative 1 times the 18. That's going to be negative 18 times x to the, well, remember we lower negative 1 by 1. We don't get 0, we get negative 2. Okay, negative 18x to the negative 2. And again, this would be the same thing as negative 18 times 1 over x to the positive 2, or negative 18 over x squared. Okay, so however you want to write your answer, it should be correct, although sometimes if you're trying to answer a question that's multiple choice, you might have got this for your answer, but then it doesn't list this as one of the choices. It might list something like this. So you do have to kind of know how to get from here to here. Okay, what about this? Now, this is not quite a polynomial here in part B, because for a polynomial, you need to have whole number exponents for a polynomial. This part in the end here would be a polynomial, but we're also including this. So what is the derivative? Well, we need to bring the 3/4 down, right? 3/4 times 5, that would actually be 15/4. X to the, well, 3/4 minus 1 would be negative 1/4. Oh, by the way, I put equals. What I should put is f prime of x is equal to this. Okay, so f of x is not equal to this. F prime of x is equal to this. 15/4. So I got that by doing 3/4 times 5. Get 15/4 times x to the, and then you remember you lower the power by 1, you get negative 1/4. 3/4 minus 1, or 3/4 minus 4/4 would be negative 1/4. Okay, plus 21x squared. Derivative of x, 7x cubed is 21x squared, plus 9, derivative of 9x is 9, and the derivative of 2 is 0. Okay, so this is our final answer. Now, again, you could rewrite x to the negative 1/4 as really 1 over x to the positive 1/4, which is really 1 over the 4th root of x. Okay, but let's continue on. How would we do something like this? Well, again, we're going to need to rewrite this. Okay, this is like 10 over x to the 1/2 power plus 42 times x to the 1/2 power. Okay, and I'm not doing any derivatives yet. I'm just simplifying things. And this would be like 10 times x to the minus 1/2 plus 42 times x to the 1/2. So 10 over the square root of x is the same thing as 10 times x to the minus 1/2 power. Okay. So again, you have to be really good at using exponents to make sure you understand how to do these problems. To do the problems, you have to be good at exponents. Okay, so what about 42 times the square root of x? That's 42 times x to the 1/2. Now, what is the derivative then going to be? F prime of x. Well, we need to bring the minus 1/2 out front and multiply by the 10. That's going to be minus 5 times x to the, well, we have to lower negative 1/2 by 1. Okay, if you do negative 1/2 minus 1, that's going to be negative 3 halves. Okay, negative 1/2 minus 1 would be like negative 1/2 minus 2 halves, which would be negative 3 halves. Okay, plus, well, we bring the 1/2 out front times the 42, we get 21 x to the, well, if we lower 1/2 by 1, we take 1/2 and we subtract 1, we get negative 1/2. Okay, so we could write this as our answer. Okay, moving on, we get our next problem, part D, f of x equals 2x to the negative 6th plus 10 over 3x to the 4th. So now let's rewrite, so the 2x to the negative 6, that's okay, we'll leave it like that. Let's rewrite this as 10 thirds times 1 over x to the 4th power. Okay, we're 10 thirds times 1 over x to the 4th. So the 10, multiply this on top, we get 10. Multiply this on the bottom, we get 3x to the 4th. So let's rewrite this. And again, we're not doing the derivative yet. We're just rewriting this. 1 over x to the 4th is like x to the minus 4th. So 10 over 3x to the 4th is the same thing as 10 thirds x to the minus 4th. Okay, now let's go ahead and take the derivative. What is the derivative? Well, the derivative of 2x to the negative 6 would be negative 12x to the negative 7. You lower negative 6 by 1, you get negative 7. Plus, well, we do negative 4 times 10 thirds. That would be negative 40 thirds. Okay, so plus a negative 40 thirds times x to the negative 5th power. Okay, now I put plus a minus. You could just put a minus. So, and in fact, let's simplify this a little bit. This would be negative 12 over x to the 7th power. Okay, x to the negative 7th is like 1 over x to the positive 7th. So that goes in the denominator. And then we could put minus 40 over and write it as 3x to the 5th power. The 3 stays on the bottom, and we have 1 over x to the 5th here. Okay, so you could either leave your answer like this, or you could simplify it and get it like this. And again, it's good to know how to simplify answers because especially if it's multiple choice, sometimes you need to know how these things simplify. Okay, moving on to the next one, we have x plus 3 quantity squared. Now, how do we take the derivative? Well, we're going to simplify it ahead of time. So how does this simplify? Well, it's not just going to be x squared plus 3 squared. That's sometimes called the freshman's dream, right? If you take the square of something like this, you can't just do this squared plus this squared. The way you have to do it is x plus 3 times x plus 3. Okay, and you rewrite this by foiling, right? X times x is x squared. We get a 3x from the inside two terms, a 3x from the outside. So that's plus 6x, and then 3 times 3 is 9. Okay, so now notice this really is just a polynomial. So the way we take the derivative of a polynomial, well, we already know how to do that, right? Derivative of x squared would be 2x. The derivative of 6x is just 6, and the derivative of 9 is 0, so we don't need to write it. Now notice we could not take the derivative of this by just doing the derivative of the first part, which would be 1, times the derivative of the second part, which would be 1. Notice that would not give us the correct answer. That'd be 1 times 1. You can't take the derivative of a product of two things just by taking the product of the derivatives. Okay, same thing right here in f. We can't just do, to find f prime of x, we can't just do the derivative of this times the derivative of this. That would give us the wrong answer, so we need to FOIL things out. So 3x times x, that'd be 3x squared. We multiply the two outside things, let's say, let's do that first. We would get 15x, 3x times 5. We multiply the two inside things, we get minus x, or minus 1x. And multiply the two last things, we get minus 5. Okay, so notice this simplifies to be 3x squared plus 14x minus 5. So now what is the derivative? Okay, we had to kind of simplify before we could take the derivative. The derivative would be 6x plus 14. Okay, what about the next example? And again, we can't just do the derivative of the top, which would be easy to do the derivative of the top and the derivative of the bottom. That'd be easy. That would give us the wrong answer. So how do we do this? Well, the way we do this is by simplifying first. So notice that if you had a fraction that was like a plus b plus c over d, isn't that the same thing as a over d plus b over d plus c over d, right? That's just how fractions work. So we can rewrite this as 7x to the ninth over x to the fifth plus 2x over x to the fifth plus 12 over x to the fifth. Okay, we just break this apart like this. This over this plus this over this plus this over this. But notice, what's 7x to the ninth over x to the fifth? Well, the x to the fifth, yeah, it's like x times x times x times x times x. And on the top, we have x times x. A whole bunch of those x's will cancel. In fact, 5 will cancel, and we'll be left with 7x to the fourth. Okay. Now, on this one, we have 2, and it's going to be over x to the fourth, actually, because we're going to have one of the x's cancel from the top and the bottom. We have that x will cancel. One of these x's will be left with an x to the fourth there. And we have plus 12 over x to the fifth. Okay, now let's rewrite it so that we can take the derivative. We can rewrite this as 2x to the negative fourth. We can write this as 12x to the negative fifth. So now let's take the derivative. The derivative is going to be 28x cubed. And then multiply the minus 4 times 2. That'd be minus 8x to the minus fifth. And then we're going to get minus 60x to the minus sixth power. Okay, so this is our answer. And again, you could rewrite this maybe as 28x cubed minus 8 over x to the fifth minus 60 over x to the sixth. Okay, and I believe we're on our last example. What about if we have 11 over the fifth root of x to the seventh power? Now, again, we need to remember what is the fifth root of x to the seventh? Well, that would be x to the 7/5 power. Okay, x to the 7/5. So the 7 is the exponent. The 5 is the fifth root is like taking something to the 1/5 power. But again, notice that this x to the 7/5 is in the denominator, so we can rewrite it as 11 times x to the negative 7/5. Okay, 11 times x to the negative 7/5. So what is the derivative going to be? Okay, again, all this stuff up here was simplifying things. We just rewrote this in a way where we can now use the power rule. So we're going to rewrite this by multiplying negative 7/5 times 11. That would be negative 77/5 times x to the, well, what's negative 7/5 minus 1? Well, it's really negative 7/5 minus 5/5. Okay, negative 7/5 minus 5/5, or negative 7/5 minus 1 would be negative 12/5. Okay, so that's how you take a derivative. And again, knowing these properties of exponents and really knowing how to use them well is going to be extremely useful and really necessary in doing these problems.